Hi and welcome back. In this video we're going to look at finding a node in our binary tree. Finding a node is actually going to be really straightforward because we've already looked at adding nodes, so we know how to navigate our tree. Let's create here a find method, and we're going to look for a specific value that is going to be an integer. Notice that the values of our nodes are all integers, so the value we're looking for is going to be an integer as well. We're going to do pretty much exactly like the add method does. We're going to start at the head, and while it exists, we are going to say if the value that we're looking for, notice this is the parameter here, is exactly equal to the current node's value, now we're not going to raise an error. We're going to say, you found it, right? This is the value we're looking for. If it exists, it means we're good. So we're going to return current node. Otherwise, if the value we're looking for is greater than the current node's value, we have to move right because we are looking for something that it must be to the right of this current node. So we'll say current node equal current node dot right. And finally, if it's not equal to and it's not greater than, that means it must be less than. Current node is current node dot left. Finally, if we reach the end of the loop and we didn't find anything, we're going to raise a lookup error. I'm going to say a node with value was not found. Now notice how here we just used else inside this if, elif, else, because the first check was the value is equal to the current node value. Second check was the value is greater than the current node value. The only thing that's left is when the value is less than the current node value. So we can use else. We could also do the same here in our add. So once again, if the node value is equal to the current node value, we raise an error. If it's less than, we go left. And the only thing that's left is when it's not equal to, not less than, that means it must be greater than, we move right. Okay? This is how you find nodes in a binary tree. So let's go ahead and go back to our app.py and print tree.find11, and we'll see that that prints out the node 11 there that was found in our tree. So I just wanted to guide you through implementing this binary tree because it's a frequent question asked in interviews and code challenges. Also, it's very used in specific parts of software development, so it's interesting to know about it. Hopefully you enjoyed learning about this more advanced data structure as well as complexity and performing binary search. Thanks for joining me, and I'll see you on the next video.